Okay, Wildcats. First off, there's a couple things that we need to address. The calendar's a little different because on Tuesday, January 16th, we had a late start day, and so we moved the calendar back. So we actually moved the test till Friday, January 19th, which moved the square root transformations to Monday, January 22nd, and we removed the inclined plane activity from the table of contents. So today we're looking at Tuesday, January 23rd, square root inverses on page 46. So if you would, update the table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, so square root inverses on page 46. There's 4 ways to find the inverse, f inverse of x. 1, graph. That means you reflect it over the y equals x line. 2, table. That's when you switch the x and y. And 3, algebraic. Switch the x and y and resolve for y. Now, before we move on to the 4th way, go ahead and update ways 1, 2, and 3. All right, now the 4th way is composition of functions. So when f of g, meaning fg of x, is equal to x, and g of f equal to gf of x is equal to x, we can say the result of f and g of f is x, then f of x and g of x are inverses. And then a special note, domain and range will switch. All right, so if you would, finish up your notes. All right, now your notes are updated. Let's take a look at the examples. All right, it says graph the inverse of f of x. State the domain and range of the function and its inverse. All right, now in order so you can see what's going on, I'm going to use some different colors. So pink will be f of x, and then we're going to use purple for the inverse and yellow for the y equals x line. Okay, so we'll have 3 colors. This is f of x, this is the inverse, and that's y equals x line. Okay? All right, so with that, let's graph f of x. So let's use the x value of 0 because we know the square root of 0 is 0, so there's your first point. Okay? When x is 1, the square root of 1 equals 1, so there's 1, 1. There's your next point. The square root of 4 equals 2, so that's 4, 2. And 9, the square root of 9 equals 3, so 9, 3. So there's f of x. So now we can use the second way using the table. So we know the table, and for an inverse, we switch the x and y. So to find f inverse of x, all we have to do is switch the x and y. Okay? So that means the y's now become the x's. So 0, 1, 2, 3 were the y's, now they're the x's. So 0, 1, 2, 3. And the x's were 0, 1, 4, 9. Now they're the y's. So 0, 1, 4, 9. Okay, so then we have 0, 0. 1, 1. 2, 1, 2, 3, 4. And 3, 9. So 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, this inverse is incomplete because the inverse of the square root of x is x, or I should say, the inverse of a square root is a quadratic. And we know this quadratic is a U shape. So we have to graph the mirror points. Well, the mirror of 1, 1 would be negative 1, 1. The mirror of 2, 4 would be negative 2, 4. And the mirror of 3, 9 would be negative 3, 9. So negative 3, 9. Okay, and so remember, the mirror points, and remember that the inverse of a square root is x squared, so you have to graph the mirror points. Okay, so now we graph the y equals x line, so 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. So you can see that this portion reflects the y equals x line. And we didn't graph it, but technically the square root is plus or minus. So technically there's the minus portion right here. So that would be a complete reflection. Okay, but we don't graph the negative square root, we just graph the positive square root. All right, so almost forgot, we have the domain. So the domain of f of x is from 0 to infinity, and then the range is from 0 to infinity. Now I noted in our notes that the domain and range switch, but this is a unique case in that the domain of a quadratic is always negative infinity to positive infinity. So you only switch the domain with the range. So the range would be from 0 to infinity. So when it comes to finding the inverse of square root of x or square root, these will switch, these won't. Okay. All right, now I know that's a lot to take in, so if you have some trouble with that, I can always go over that again in class. But if you understood it, let's move on to example 2. All right, example 2. So you want to be selective when picking points. I'm going to start off with -3 because I know -3 plus 3 is 0. Okay, and so that would be 0, and then your y value is -2. And then I'm going to pick -2 for x because I know -2 plus 3 is 1. So that's square root of 1 is 1, and that's -1 minus 2 is -3. And then I'm going to use the next point as 1 because I know 1 plus 3 is 4. So square root of 4 is 2. So that's -2 minus 2 is -4. And then my last point I'm going to use is 6 because 6 plus 3 is 9. Square root of 9 is 3. That's -3 minus 2 is -5. So that's -3, -2, -2, -3, 1, -4, and 6, -5. Now, in this problem, I'm actually going to start and do the domain first in range for the f of x. So that's sometimes it's easier to do it because you're just looking at that. You don't have to. You can do it the other way in example 1. But here, so then the domain would be from -1 to -3 to infinity. And the range would be from -infinity to -2. Now remember, we don't graph it, but technically there's a negative square root. So technically this is there, but we just don't graph it. Okay? All right. So now let's find the inverse. So f inverse of x. So to find that, we just switch the x and y values. So then the new x's are -2, -3, -4, -5. And the new y values are -3, -2, 1, 6. So then that's -2, -3, -3, -2, -4, 1, and -5, 1, 2, 3, 4, 5, 6. But remember, the inverse of the square root is a quadratic, so we have to graph the mirror points. So the mirror point of -1, 2, 3, -2 would be 3. Let's see, the mirror of that would be this point. So the mirror of that would be actually And the reason I say mirror is I cut this in half. So there's your mirror point. So your mirror point of -3, -2 being -1, -2. And then the mirror point of this one, you just count. So this is 2 away from the axis of symmetry. So I go to the right 2. So that point is 0, 1. And then this point is 1, 2, 1, 2, 3 from the axis of symmetry. So I go 1, 2, 3. So this point is 1, 1, 2, 3, 4, 5, 6, 1, 6. So what we mean by mirror is we cut the graph in half, and it's a mirror image like that. And so you can't forget about graphing the mirror image, okay? And then graph y equals x line, which I should have labeled this as y equals x here. So y equals x is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. And you can see here that they reflect over the y equals x line, and then the domain. Now, the domain remains switch, except for this is special. The domain of a quadratic is always -infinity to +infinity. But then you can switch here that your range is from -3 to infinity. All right, so remember, if there's any questions on that, if you'd like me to go over the example completely in class, just let me know and I can do that. Now let's move on to example 3. All right, determine by composition whether each pair of functions are inverses. Okay. Now, in this case, we're going to use blue and red. Okay. So f of x is blue and g of x is red. Okay. So we're going to do f of g so that's the square root of x minus 1 squared plus 1. Okay, so basically what we're saying is g of x went into f of x. Now we simplify. This becomes the power of 1, so we're left with x minus 1 plus 1 which equals, and I'm actually going to steal that line. I'm going to move it using something called whiteout. It's pretty cool stuff. And I'm going to move this line right here. So -1 plus 1 equals x. So we can say that f of g equals x. So far they can be inverses. Now we need to do g of f. So that is when we put f of x into the g of x function. So that is square root of x minus 1 squared. Oh, wait a second. We're making some mistakes today. Square root of x plus 1 minus 1 squared. Almost made a mistake. All right, now plus 1 minus 1, they cancel, so you're left with the square root of x squared, which again equals x. So we can say that g of f equals x. And f of g equals x. So we have f of g equals x and g of f equals x. So from our notes, we can say that f of x and g of x are inverses. All right, so now let's look at example 4. Remember, if any time you have trouble with these and you're like, man, I'm having some trouble, I can always go back over this in class. And I'm actually going to go over this in a little darker pen so you can see, because that whiteout kind of messed things up. So you can see that equals x, and then this was the square root of x squared equals x. Try to draw these a little bit better. All right. So now we're going to do f of g equals so this is we're going to put g of x into f. So that's 3 times the square root of 1/3 x squared. So that becomes 3 times the square root of 1/3 the square root of x squared. Now the square root of x squared, that becomes to the power of 1, and then you're left with 3 times the square root of 1 divided by the square root of 3 times x. You can see that 3 and the square root of 3 aren't going to reduce, so f of g is not going to equal x. So at that point you're done, because remember they both have to equal x. So since one doesn't, then we can say automatically that f of x and g of x are not inverses. All right. So, and again, remember, if at any time if you had some trouble with those, let me know. I can work them again in class with you. Okay. Let's look at the next examples. All right. Now, examples 5 through 8 say find the inverse of each function and state the domain and range for both functions. So now we're getting into finding the inverse algebraically. Now, to find it algebraically, you switch the x and y and then resolve for y. So we're going to switch the x and y. So x equals 3 square root of y minus 2. So now we've switched the x and y, and we're going to resolve for y. So our first step is we're going to divide both sides by 3. Three divided by 3 is 1, so then you're left with x divided by 3 equals the square root of y minus 2. So then we square both sides. And so then you have x squared divided by 9 equals, now this is where you have to kind of be mindful of your work. We know we're going to add 2 eventually to both sides, so we're actually going to leave some space here. Okay, so then this becomes the power of 1 y minus 2. So then the last step is we're going to add 2 to both sides. So we can say that y equals x squared divided by 9 plus 2. And that probably line went way too low. Kind of cut into the range work. All right, so domain. Let's look at domain. Again, we're going to color coordinate these. All right, so domain of f of x. And you should be able to understand domain without graphing it. So we know that this domain has to start at 2 because 2 minus 2 is 0. So then we know that the domain is from 2 to infinity. Now the range, there is no vertical translation. So we know we start at 0. So the range is from 0 to infinity. Now remember the inverse of squared is squared, and the x squared domain is always negative infinity to positive infinity. But then you know that the domain and range switch, so the range is 2 to infinity. All right, so again, if you have some trouble with that, let me know. We can go over any and all of these examples in class. But if you understood them, let's look at example 6. All right, so example 6. First step is we're going to switch the x and y. And another thing is you don't actually have to watch the entire video. If you understood example 5 and you know how to use that to answer 6, 7, and 8, then you could stop the video right now and just do the examples on your own. All right, so first step is we're going to multiply both sides by 2. Actually, let me take a step back before that. We actually need to add the 4 to both sides. And that's where, again, you want to be conscious of knowing that step. So in this case, I'm going to move the x a little farther to the left so that I have space to add the 4 to both sides. Okay, so then we have x plus 4 equals 1/2 square root of y. So now we need to multiply both sides by 2. Now here's the thing, you don't actually want to multiply 2 by x and 4, you just want to say that I'm multiplying 2 times x plus 4 equals the square root of y. And so then our next step is we want to square both sides. And then we are done because the square root and squared becomes power of 1, so you're left with y equals 2 squared is 4, and x plus 4 squared is x plus 4 squared. All right, so to find, and again, we want to color code these. I'm going through and color coding all of them so I don't have to keep doing that on each. All right, so domain. Again, you should be able to look at domain from the function. So we see that the square root, remember the square root has to start at 0 because you can't have a negative number. So that's our farthest left point. Okay, so the square root of 0, so x is 0, so then that's 0 to infinity. Then here, the graph went down 4 units, so our range starts at -4, so -4 to infinity. Now remember, the domain of a quadratic is always -infinity to positive infinity, and then we know that when you do inverses, the domain and range switch, so the range would be 0 to infinity. And normally these would switch as well, but it's a special case from going to a square root to a square. All right, so let's move on to example 7. All right, so again, first step is we're going to, now understand something, is that you have to remember that f of x is equivalent to y. So we can actually just write a y over f of x. Okay, so we know that's y. Okay, so we switch x and y, so x equals, and again, you want to be conscious of, you see the 4, so we're going to subtract that 4. So you actually want to leave space so you can subtract the 4. Okay, so our first step is we're going to subtract, and this is I make this sometimes, is that should be a y. So I know we're switching x, y, but I forgot it to change that to a y. Okay, so we subtract 4 from both sides. So we get x minus 4 equals the square root of 2y minus 1. Our next step is we're going to square both sides. So then you have x minus 4 squared equals, this becomes the power of 1. And again, being conscious, you're going to add the 1, so you want to leave some space when you do that. So 2y minus 1. Add 1 to both sides. So you get x minus 4 squared plus 1 equals 2y. Our last step is we're going to divide everything by 2. Now, a lot of you want to just draw one line, put a 2 here, but I recommend actually dividing it by 2 here and here. And so then we're done. So then we have y equals x minus 4 squared divided by 2 plus 1/2. And the reason why I would do it that way, because this 1/2 is the y-intercept, okay? And this 1/2 here is the vertical compression or a stretch. Figure which one's which. All right, so domain. You look for when x will be 0. So when x is 1/2, 2 times 1/2 is 1, 1 minus 1 is 0. So that's where this domain starts. So it goes from 1/2 to infinity. And the range, it translated 4 units up, so the range starts at 4. So 4 to infinity. Now, normally these would switch, and this would be 4 to infinity. But remember, quadratics, the domains are always -infinity to positive infinity. But this domain and range can switch, so then that's 1/2 to infinity, which makes sense because here we're starting at 1/2. All right, last example, example 8. So again, f of x is y, and then switch x and y. So x equals the square root of, I'm going to go ahead and the negative's in front, but I'm going to move it with the x. So negative x divided by 3, and then the plus 6 on the outside. And again, I always make that mistake. This should be a y. So just be careful not to keep make that x and x, but that should be a y. And it's not a mistake, but it makes it work easier if you move this x over, because we know we're going to subtract 6 from both sides. So then you have x minus 6 equals the square root of negative x divided by 3. All right, and then we're going to square both sides. So then you have x minus 6 squared equals the square root becomes the power of 1. And now I'm actually going to move the negative on the bottom, and make this x divided by -3. And you can do that because technically the negative's in front, so it can be in the numerator or the denominator. And this should be a y. And then our last step is multiplied by -3, so then y equals -3 x minus 6 squared. All right, so for domain, we want to know when the x will be 0, because that's the farthest left you can be with the square root. So when x is 0, it's square root of 0, so 0 to infinity. And the range, this went up 6 units, so this is from 6 to infinity. All right, and then the domain, again, is always from -infinity to +infinity. And this should be from 0 to infinity. Now, you should be able to do these all without a calculator, but it's good to check. Now, I've used a calculator to check, but something worries me about this one, and that negative inside of the square root makes me concerned about my domain. There were any other ones that had that negative in front that I believe that's concerning, but I'm going to graph this. So I'm going to go to New Document, No, Add Graph, and I'm going to graph that. So that's the square root of -x divided by 3 plus 6. And then I can actually control click, and I can grab the screen, and I can pull it down so I can see. I can actually move it there. And I suspected that negative reflected the graph across the y-axis. So we need to reconsider our domain and range. So in this case, it's actually and I think it only affects the domain. Yep, so the domain should actually be from negative infinity to 0. Okay, and then 6 to infinity was fine, which would make this from 0 to -infinity. So again, it does pay off to graph it just to check, because it's easy to make a mistake. In that case, I made that mistake because I forgot about the negative on the square root. And so I'm just going to go through and see there's no negatives involved either inside or outside. None here. And then there was one there, but we did it graphically, so it worked out okay. All right, so at this point, you have two options. If you have some questions, you could wait and I'll go over them in class with you on the examples, or if you understood all examples, I would start working on the assignment now. Either way, have a wonderful Wildcat day.